Okay, now you're doing exponential graphs. I want to draw your attention to the formula at the top of the page. Y equals a to the power of x plus b in brackets, and then plus c at the very end. Okay, now this b number is really the horizontal shift. In other words, is the exponential gone that way or this way? This one here is the vertical shift. Has it been moved up or has it been moved down? Don't forget that when we're talking about horizontal shifts, if it's gone in the positive x direction, we have to write minus there. If it's gone in the negative direction, negative x direction, I mean, then we write a plus sign there. Okay? Now, in this first example here of these exponential graphs, it says that in these graphs, only the base has changed. So in other words, there has been no horizontal shift and there's been no vertical shift. So the values of B and C are both 0. All right, so how do we do this? Well, there's the A graph doing this. And there's one important thing to notice about all of these graphs is that they all pass through that point there, which is 0, 1. Because when you write the equations, y equals a, you don't know a, the base, to the power of x, when x is 0, anything to the power of 0 is 1, which is why all these exponential graphs go through that very unique point. Okay, now that's a very important point to keep hold of, because when we come to look at horizontal and vertical shifts, you are using this point all the time to find out what what B and C are. All right, so let's do the first one, A. Well, you start off by writing y equals a to the power of x. We don't know a. So what we do is we go along the graph looking for a nice point. Well, there's one there, which is 3, 8, but try to keep the numbers small if you can. Going down, 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 there's another one. Now that's the one I've chosen, 2, 4. Okay, so you use 2, 4 to find a. Well, you put 4 equals a squared, x is 2 and y is 4. Well, you take the square root then of 4 to find a, and a works out as 2. So your formula is y equals 2, the base 2, to the power of x. In B, which is this one here, again, we start off by writing y equals a to the power of x. We don't know a. And we're going to use 1, 5 to find a. Well, I go along the graph to find a nice point, and it is going through that point there at 1, 5. So you use that to find a. Well, it means you write 5 for y equals a to the power of 1. Well, if a to the power of 1 is 5, then a must equal 5. So this formula is y equals 5 to the power of x. Now, the exponential graph C, you'll notice that now we're dealing with exponential graphs going this way. These will have negative powers involved, okay? So let's see how they work. Well, they work in exactly the same way. I write y equals a to the power of x, and I go along the graph looking for a nice point through which the curve goes, and the one I found was that one there, which is 1 minus 10. So I'm going to use 10 for y and minus 1 for x. So it's 10 equals a to the power of minus 1. Well, if it's to the power of minus 1, if I bring it down below and make it a fraction, it's 10 equals 1 over a. That a, of course, is the power of positive 1 now. And so if I cross multiply the a up there and the 10 down there, a is 1/10. Okay, so you can write y equals 1/10 to the power of x. Well, of course, if I bring that 10 in the denominator up to the numerator, the power of 10, which is positive 1 in the denominator, it becomes negative 1 in the numerator. And so I've got 10 to the power of minus 1 all to the power of x. Well, if I get rid of the brackets by multiplying in the x there with this power of minus 1, then I get y equals 10 to the power of minus x. Okay? So you need to be very good to know how to work your powers when you change them from powers in the numerator to the denominator and denominator back to the numerator. In D, we're doing exactly the same thing. We write y equals a to the power of x, always start off like that, and we look in D for a number, point to which it goes. Now there's one there which I didn't use, minus 1, 2, but I could have used it. I went along and I did that one there. Okay, minus 2, 4. And I used minus 2, 4 to find a. Again, I wrote 4 for y and minus 2 for x. Well, don't forget, if it's a to the power of minus 2, that is really 1 over a to the positive 2. There it is, 1 over a squared. And if I cross multiply, the a squared goes up there, the 4 goes down there, they swap places, and so a squared is 1 over 4, so a is the square root of 1 over 4, which is 1 over 2. So in other words, a is a half. If I bring the 2 on the bottom of the half up to the numerator, it becomes 2 to the power of minus 1. And again, that's going to give me 2 to the power of minus x. So the 2 is raised to a negative power in this case. Okay? All right. Now, I hope you understand that. If I move up to these graphs, you'll now see why the keeping an eye on the point 0, 1 is very important. Okay, so we're going to do graph E, which is this green one there. Okay, so what you're doing is you're looking at the point 0, 1. Now 0, 1, don't forget, was that point there. And this time the graph has undergone a shift. Okay, and in our case, we say to ourselves, where has that point 0, 1 gone to in the graph there, the E1? Well, you can see it's gone down there to, and it's dropped 2 points, 2 units down in the Y direction. So you can see here, there's been no horizontal shift, but there has been a vertical shift. And so it shows that there's 0 being added to the x because there's no horizontal shift, but there is minus 2, which drops it down 2 units. So we can use that point there, 2, 2, which is on the graph. We use 2, 2 to find a. So I write 2 for y, a to the power 2, or a squared, take away 2. Well, that take away 2, that minus 2, can go over the equal sign, and that becomes 2 plus 2, which is 4. So 4 is a squared. So a is 2, just taking the square root. So your final equation is y equals 2 to the power of x, take away 2. Now the graph F is slightly different because there's the graph F. And again, we ask ourselves, where has that point 0, 1 gone to in the new graph? Well, it's gone there. And you can see that it has gone 4 units in the positive x direction. So we've got to write minus 4 there. But because there has been no vertical shift, this thing here, there's a 0 on the end. So the final equation, don't forget that a is always 2. The final equation is y equals 2x to to the power of minus 4. Sometimes you should be writing that in brackets. Now the same is true for g. G, there it is, there's g. And you ask yourself, where's the point 0, 1 gone to? Well, if you go up like that, there it is. It's gone to 4. But be very careful here. It has not been moved up by 4. It's been moved up by 3 because it's already at 1 on the y-axis. So it's gone up 3 units. And there's been no horizontal translation. So it's going to be a 0 behind that x. So it's y equals 2 to the power x plus 3. And when it comes to the last one, h, there it is. H is there. And again, we ask, where's this 0.01 gone to? Well, it's gone 3 units that way. And so if it's gone that way 3 units in the negative x direction, we must write 2x to the power plus 3. Okay. And the final thing you should look at is this bit at the bottom here. Okay. Remember to ask, where has the point 0,1 moved on the graph? So here I've got, there's my 0, 1, and I've drawn this new graph there. Okay. And so you say to yourself, well, where's it gone to, this 0, 1? Well, it would have gone 6, 3 on this particular one. Now, the 3 is, this point here is 1 unit above the asymptote y equals 3, just as this point here is 1 unit above the asymptote, which is the x-axis. Okay, so it's y equals a x to the power of minus 6 plus 3 upwards. And to find the value of a, you choose a point on the curve, which I did there, 8, 12. I've explained it there, and I've also here tried to draw your attention to remember that the new point where that one's gone to, it must be 1 unit above the new asymptote at minus 3. All right, I hope that helps you to do page 14.